Everybody, welcome to another fun and exciting geometry class. Today we are going to be in your book. On page number 71, we're going to be in lesson 2.11. 2.11 is angles formed by parallel lines. Last lesson we were talking about parallel lines. This lesson we're again going to continue. I'm trying to learn just a little bit more about how we can use these in our proofs, how we can use these as we are trying to prove things to be true. So what I have on the screen here, and you can see, is I have just some parallel lines cut by a transversal, and I've got the angles numbered. Now, if you look in your book, the book has them with letters, and I don't like it. So I think it's a little bit confusing, and so what I did was I put numbers around it. So if you can kind of look what's going on in the book, but kind of pay attention here on the screen, and you will see as we talk through it, I think it'll make a little bit more sense with these numbers than what you're looking at with the letters in the book. So let's start with theorem number 8. Theorem number 8 says, if two lines or two parallel lines are cut by a transversal, then their alternate interior angles are equal. All right, so what is that saying? That's really the converse of Theorem 7, if you think about it. Theorem 7 was that they are parallel lines if their alternate interior angles are equal. Now this is saying if they are parallel lines, and we're saying that they are, then those alternate interior angles would be equal. So if down here at postulate, I don't know why I wrote postulate 8. I don't know what I'm doing. It's not a postulate, it's a theorem. So let's change this. There we go, theorem 8. So theorem 8, here's what it says. If we look here, we would say that 3 is an interior angle. What is its opposite interior? 5. So if they're parallel, and they are, then 3 equals 5. Angle 3 equals angle 5. That's what theorem 8 says. The other one is angle 4 equals angle 6. 4 equals 6. So, and angle 4 equals angle 6. So those are the two that are proven by theorem number 8. Theorem number 8 says that if they're parallel lines, and these are, now they might not be because I just drew them, but we're saying that they are. 3 equals 5 and 4 equals 6. That's what theorem 8 says. Now, what if these lines aren't parallel? So what if I have a line coming up like this? Then you throw it all away. You have to start with the premise that these lines right here, we could call this line AB and this line CD. We have to start with the premise that AB is parallel to CD. That's where we have to start in this theorem. If we don't start with that, if somebody doesn't tell us that, then none of the other things can be proven. So that would have to be in your given, okay? And so this is in our given right now. This is something that they told us. They told us that AB is parallel to CD. All right, so in this case, 3 equals 5 and 4 equals 6. That is theorem number 8. So alternate interior angles are equal. All right. Skip down page 71, continuing down, Corollary 8.1. Corollary 8.1 says if two parallel lines, and that's what we have, AB is parallel to CD, are cut by a transversal, it is, the transversal, I guess in this one would be EF. Okay. So it's cut by transversal EF. Then the corresponding angles are equal. Interesting. Then the corresponding angles are equal. Well, what are corresponding angles? Well, that's important. What angle corresponds with number 1? Remember, corresponding means if we can take it, it's like postulate 5. Postulate 5 means that we can move things freely in space without changing them. So if we moved AB and put it on top of CD, what angles would be sitting on top of each other? That's a corresponding. 1 would correspond with 5. Okay? So we could come down here and say angle 1 is equal to angle 5, because those are corresponding. We could also say that 2 is equal to 6. We would also say that 4 is equal to 8. And then, obviously, the last one would be angle 3 is equal to angle 7. Angle 3 equals angle 7. Okay? And so those are the corresponding angles. And that only works if those lines are parallel. Well, good news, they are parallel. We've got that right there. Okay? So continuing on, let's turn the page over to page 72. Page 72. And we have Corollary 8.2. Corollary 8.2. If two lines are cut by a transversal, two parallel lines are cut by a transversal, that's what we have, then the sum of the two interior angles on the same side of the transversal is equal to a straight angle. So let's kind of rewind that. The sum of the two interior angles on the same side, not the alternate interiors, the same side, these two or these two, is equal to a straight angle or is equal to 180. So 4 plus 5 equals 180. Angle 4 plus angle 5 equals 180, straight angle. Okay, so that's 4 and 5. These are on the same side of the transversal right there. Okay, and then 3 and 4 are also equal to 180. Okay. All right, so that equals a straight line. Now let's look at that and let's kind of make that make a little bit of sense. All right, so what we said was 3 equals 5. Remember when we said that? Alternate interior angles are equal. Now look at 3 and 4. Well, that's a straight angle right there, right? 3 plus 4 is a straight angle. So if 4 plus 3 equals 180, then 4 plus 5 equals 180 also, because 3 equals 5. Where did that come from? 3 equals 5 came from theorem number 8. Okay, so theorem number 8 was 3 equals 5. And so if 4 plus 3 equals 180, and it does because it's a straight line, then we also know that 3 plus 5 equals 180. So that's Corollary 8.2. All right, the next Corollary 8.3. When two straight lines are cut by a transversal. Now, these aren't even necessarily parallel. It just says when two straight lines, doesn't say parallel lines, are cut by a transversal. If the sum of the interior angles on the same side of the transversal does not equal a straight angle, then the two lines are not parallel. So this one's kind of like almost the inverse of 8.2. In other words, if 3 and 5 do not equal 180, then the lines are not parallel. I don't really know why they stuck 8.3 in there. It's kind of a weird place to me. I think that should be under Theorem 7, but it's here under Theorem 8. So it's kind of like a converse, if you will, of the last Corollary 8.2. So if they're not equal to 180, then the lines are not parallel. Okay. All right, next one is Corollary 8.4. Corollary 8.4 says, a straight line perpendicular to one of the two parallel lines. All right, so a line perpendicular to one of. So let's say, again, this would have to be in the given. It says, and let's label this EFGH. GH. So we would have to say somewhere that GH is perpendicular to AB. Let's just say that. Let's say that's in the given. GH is perpendicular to AB. Okay? What else do we know? Well, you might be able to figure it out. If this line is parallel, and it is right there, then guess what? It is also perpendicular to this line, GH. It has to be. Because if GH is perpendicular to AB, and if AB is parallel to CD, then GH is perpendicular to CD. No other option. It has to be. Okay? So if you can prove that, and there's some reasons why. I mean, think about this. Look at the alternate interiors. So if this is 90, then this is 90. So then it would have to be, okay? Because alternate interior angles would be equal, and then that would make this a right angle, which would make it a perpendicular line. So some interesting stuff there, but it all is connected together. If one thing is this, then the other thing has to be that too. Okay. All right, last one. Corollary 8.5. Corollary 8.5 says, lines perpendicular to non-parallel lines are not parallel. This is kind of like the converse of Corollary 8.4. So now let's go down here to Corollary 8.5, and let me just draw some non-parallel lines. Okay, those lines are not parallel. Some of you are like, okay, they're not, trust me. All right, so if I have a perpendicular line, and it's perpendicular to this line, then I'll tell you something, it is not perpendicular to this line. It can't be. The only way that it could be perpendicular to that line is if this line was parallel to this line. Okay? So if they're parallel, then it would be perpendicular to both. If they're not parallel, then they're not perpendicular to both. Okay? So Corollary 8.5 is just like the opposite of 8.4. All right. Hopefully that kind of pulled some things together for you. Maybe not. Maybe you're still struggling with this idea of perpendicular and parallel. Keep working on it. Go back and watch some of these videos again. But I think the key is this. The key that you have to get, the key that you have to understand right here is these things are all tied together. These angles, those are interior. So these ones are a straight angle. These ones are a straight angle. This one equals this one. Okay? So that means that these are a straight angle. Then that means that these are a straight angle. Okay? And we haven't really even talked about the exterior ones yet, but let's connect those real quick. If 3 equals 1, and they do because they're opposite, look, 3 equals 1, then 1 and 6 equal a straight angle. Why is it, what? No, look, if 3 and 6 equal a straight angle, and 1 equals 3, then 1 and 6 equals a straight angle. And watch this. If 6 and 8 are equal, then 1 and 8 equals a straight angle. okay? So you can work your way around all these things, and they all equal different things. They all, and we're going to see this in a little bit. It's a really fun exercise. Okay, if I say angle 2 equals 63, you can tell me from that statement right there, you can tell me what every other angle equals right here. Okay, what does angle 4 equal? Well, it equals 63. Well, if angle 4 equals 63, then angle 6 equals 63. If angle 6 equals 63, then angle 8 equals 63. Okay, if angle 2 equals 63, then 1 equals 180 minus 63, 117. So angle 1 equals 117. If angle 1 equals 117, angle 3 equals angle 17. If angle 3 equals angle 7, you see what I'm saying? It all connects around. And so that really there's only 2 different degrees here. There's only 2 different angles. There's the angle 1s, the ones that match angle 1, and the ones that match angle 2. Okay? So you have to figure out how to work your way around those things. So some of you are still looking at that going, wait a second, that can't be right. So figure it out. It is right. And so go through it and check it out and work on this. If you missed anything right there, rewind the video, check it out again, make sure that you don't miss anything. That is very, very important stuff right there for the rest of geometry. Okay? All right, we'll see you later. Have a good one. Bye-bye.